The asteroid is confirmed. Impact in 18 months, no deflection possible. Every government on Earth receives the same classified briefing simultaneously. Humanity has 1.5 years to save as much of itself as possible. Tonight we're not asking whether we should leave Earth. We're asking whether we actually could, and what that plan would realistically look like. The science, the logistics, the hard choices, and the destination. This is humanity's real escape plan. The uncomfortable truth is that 18 months is nowhere near enough time to evacuate meaningful numbers of people. Building a single large rocket takes years. The International Space Station, humanity's only permanent off-world habitat, supports 7 people. Earth's population is 8 billion. The math is brutal. What 18 months could accomplish is the preservation of knowledge and genetic material, digital archives, seed banks, DNA repositories, launched to stable orbits or buried in deep geological formations on the moon. The physical survival of large human populations would require decades of preparation, which raises the real question: why haven't we started? Mars is the obvious first destination. It's close, 6 to 9 months travel depending on orbital alignment. It has water ice at the poles and potentially underground. Its gravity is 38% of Earth's, livable with adaptation. SpaceX's Starship, if fully developed, could carry 100 people per launch. At maximum launch cadence, one launch every few days during optimal orbital windows, a Mars colony of tens of thousands of people could theoretically be established within a decade. But Mars is not a backup Earth. It's a frozen desert with almost no atmosphere, surface radiation that would be lethal without shielding, and no magnetic field. Surviving on Mars long-term requires living underground. It's a bunker, not a new home. For true interstellar escape, leaving the solar system entirely, we need something no one has ever built. A generation ship, a self-contained world, large enough to sustain a population of thousands across multiple generations, traveling for decades or centuries to reach another star. The engineering requirements are staggering. The ship must recycle all water and air indefinitely. It must grow all its own food. It must maintain psychological health for people born, living, and dying entirely in a metal cylinder in space. It must carry enough genetic diversity, minimum estimates suggest 10,000 to 40,000 people, to avoid inbreeding collapse over generations. And it must be structurally reliable for centuries without the ability to call for repairs. The biggest engineering challenge is speed. With current chemical rockets, reaching Proxima Centauri takes 70,000 years. That's not a generation ship, that's an eternity ship. Viable options require fundamentally different physics. Nuclear pulse propulsion, detonating nuclear bombs behind the ship, could reach 5% of the speed of light, cutting the journey to Proxima to about 85 years. A laser sail, using a massive ground-based laser array to push a lightweight ship, could theoretically reach 20% of light speed, arriving in about 21 years. Antimatter propulsion, the most powerful theoretical option, could reach 50% of light speed, but producing antimatter in meaningful quantities requires energy, equivalent to thousands of nuclear plants running for years. This is the question that makes every other challenge look simple. If we can save 10,000 people, out of 8 billion, how do we choose? By skill, by age, by genetic diversity requirements, by lottery, by wealth, whoever can pay for a ticket. Every answer is a moral catastrophe in some dimension. A selection by skill means saving scientists and engineers but leaving behind artists, philosophers, children, the elderly. A lottery is fair but random, the survival of human civilization left to chance. Selection by genetic diversity treats people as breeding stock, and selection by wealth, the most likely outcome given how the world actually works, means the survival of humanity is determined by who had the most money before the apocalypse. There is no good answer, only least bad ones. Proxima Centauri B remains the most tantalizing destination, a confirmed planet in the habitable zone of the nearest star, but the journey reveals its complications on arrival. Proxima is a red dwarf, smaller, cooler, and far more prone to violent flares than our sun. Proxima B is likely tidally locked. One side in permanent day, one in permanent night. The habitable zone, if it exists, might be a narrow band between scorching and frozen. And the radiation environment from Proxima's frequent flares could be harsh enough to strip the atmosphere over geological time. It might be habitable, it might be Mars. We won't know until we're there. And at that point, there's no turning back. The hardest part of leaving Earth isn't the engineering, it's the leaving. Every piece of art ever created, every building ever constructed, every grave, every landmark, every ecosystem, the accumulated culture of 300,000 years of human history, left behind. The survivors would carry copies, digital archives, cultural artifacts, biological samples. But copies are not the things themselves. The Louvre can be photographed, but not transported. The Grand Canyon cannot be copied. The specific chemistry of Earth's oceans, the product of 4 billion years of biological and geological history, cannot be replicated. Whatever humanity becomes on a new world, it will carry the memory of Earth. But the real Earth, the actual place, will continue without us, slowly healing, perhaps eventually supporting new life that evolves its own intelligence, its own art, its own questions about the universe. Here's the thought that ties this entire series together. We started this journey asking what happens when something destroys Earth, a rogue planet, a gamma ray burst, a dying core, a disappearing sun, and every answer led to the same place. Life continues. Not necessarily us, not necessarily on Earth, but the chemistry of life, scattered by the explosion of a star, seeding new worlds across the galaxy. We are made of atoms that were forged in stars that exploded before our sun was born. When Earth ends, whenever and however that happens, those same atoms go on. They become part of new nebulae, new stars, new planets, new chemistry, perhaps new life, perhaps new intelligence, asking the same questions we're asking tonight. The universe doesn't end stories, it transforms them. We built a new home among the stars, but Earth is still out there, drifting alone in the dark, slowly healing, waiting. What happened to it after we left? That's where this whole journey started. Go back to episode 1, the link is right here, and experience the full series from the beginning. And if you're not subscribed yet, hit that button right now. This channel is built for people who can't stop asking what's out there, and there's so much more coming. See you in the next one.